Okay, so today I will discuss one final problem, and that will cover two concepts. One is the concept of the artificial variables, and one is the concept of what we call as the minimization problem. Okay, so far we haven't discussed any minimization problem. Let's discuss the minimization problem. The problem is minimize z equal to seven x1 plus 5x2 subject to x1 plus x2 greater or equal to 4. And the second constraint is 5x1 plus 2x2 x1 plus 2x2 is greater or equal to 10. Okay, so this is the question which we are going to discuss here, and the decision variables are greater or equal to 0. So first of all, you can see that this problem is of minimization. So this is the first question which you are solving related to the minimization, but it's not different from that of the maximization. Same thing will be used to what we have used it in the maximization problem, only just one change. That is, we convert this minimization problem into the maximization problem. I will discuss it soon. And see here, what is the second thing that we have to see here? These constraints are greater than constraints. Okay, you can see that these constraints are greater than constraints. Till now, we have only dealt with the constraints which are less or equal to constraints. Okay, there we use it to add slack variables. Okay, there we use it to add the slack variables. Here you can see that the left hand side is greater than the right hand side. In the constraints, the left hand side is greater than the right hand side. Therefore, we can see that we have to subtract something from it. Okay, we have to subtract something from it to make it equal to the right hand side. Okay, only after the subtraction we can get the term in the left hand side equal to the right hand side. And since we have to subtract it, जो चीज हम subtract करते हैं, that is in the surplus quantity. Okay, you can see that the left hand side is surplus. Therefore, what we have to subtract from the left hand side is the surplus variable. So this problem will become the first constraint according, okay, for the time being it can become, okay, since we have to subtract from the left hand side, therefore x3 we have to subtract. Similarly, the second constraint will become, that has to be equal to 10. Okay, this will be equal to 10. So we can see that we have these x3 and x4. These are known as surplus variables. Okay, these are known as surplus variables. So, but we can't only take into account the surplus variables. Okay, this is not the complete conversion of the problem. Okay, of these constraints, we have to do something more. Okay, but I will go by step by step. First of all, I will tell you why this is not the sufficient, that is introducing x3 and x4, why it is not sufficient, okay, for our problem. So if the problem is like this, okay, there are the two constraints, we can see that we have, currently we have 4 variables and we have 2 equations, and n minus m variables have to be fixed to 0, that is they are the non-basic variables. So currently we have to fix 2 variables which are the non-basic. And obviously we would like to start with the surplus variables. ठीक है, मैंने उस time भी कहा था that we start with these variables as the what we call as the basic variables. Okay, so the non-basic variables will be x1 and x2, and the basic variables will be x3 and x4. But if we are starting our solution with x3 and x4, we are what we like in the first solution, that under the basic variables we always get an identity matrix. The identity matrix in the order of x3 and x4 should have been 1 0 and 0 1. But if we look at the first constraint, in the first constraint we have x3 coefficient is equal to -1 and the coefficient of x4 is equal to 0. In the second constraint, the coefficient of x3 is equal to 0, and in the right hand side, and here the coefficient of x4 is equal to -1. But this matrix is not an identity matrix. Okay, it is not an identity matrix because we would like to have 1 0 and 0 1 here. It's not an identity matrix. So this is the issue which is arising if we are only going for these surplus variables. X3 and x4 are the surplus variables, but we can see that to begin a solution, we can't begin the solution with these surplus variables, because in the first simplex table we won't get the identity matrix in the order of x3 and x4. Okay, so this is the first limitation. Now one more limitation here is that if I write the constraints again, x1 plus x2 minus x3 is equal to 4. Okay, if I'm writing this first constraint, let me, in the first iteration, what we do in the first step, we bring the basic variables in terms of the non-basic variables. Okay, so x3 is the basic variable and it has to be brought in terms of the non-basic variables. That is possible when this above equation will become this. Okay, that is x3 has been written in terms of the basic and non-basic variables. And in the first solution, the x1 and x2 are the non-basic, that is they are equal to 0. So from here, what is the solution? We are getting that the solution is equal to x3 is equal to -4. But this is not possible. X3 has to be greater than 0. X3 has to be a positive or equal to 0 at max. Okay, but we are getting that the x3 is equal to -4, but this is not the possible because all the decision variables should be what, and they should be positive. तो आप देख सकते हैं इस इक्वेशन में अगर हम यहाँ पे x3 का वैल्यू नेगेटिव अगर आता है, ये फर्दर increase हो जाएगा. Okay, LHS is greater than RHS. When we are putting a negative value of x3 here, this minus and minus will become plus. The value of the constraint from the left hand side will increase further. Okay, so this is another limitation here. Okay, therefore it is not possible to start with these only surplus variables. Okay, यहाँ से हम सिर्फ surplus variables से start नहीं कर सकते हैं. So what we have to do is we have to add some another variables, and those variables which we are adding are known as the artificial variables. The variables which we are adding are the artificial variables and they are denoted by small a. So let me add the artificial variables and see what I get. The first constraint was x1 plus x2 minus x3, and now I am adding another artificial variable, an artificial variable, that is a1. Since I have to use two artificial variables here, therefore first artificial variable will be a1. And if I am looking at the second constraint, I have to add another artificial variable, that is 5x1 plus 2x2 minus x3 x4, 5x1 plus 2x2 minus x4 and plus a2. This should be equal to what? From the right hand side we have 10. Okay, from the hand side we have 10. So I have added two artificial variables here, a1 and a2. And in this, what I will do here, see here again, now see here, now the number of variables have increased. Okay, now the total number of variables are, if I count the variables x1 x2 x3 x4, and a1 and a2 are the further two addition. ठीक है, पहले चार थे, अब दो artificial variables add हुए. So the number of variables are what, 6, and still I am having two equations. Then I have to put n minus m as the non basic variables जिनका value मुझे 0 fix करना होता है, and currently it is what 4 variables I have to fix as the non basic variables. Therefore again we will have 2 basic variables. And now these 2 basic variables will be, I will start with artificial variables as the basic variables. These artificial variables will be the basic variables. Okay. So in the first table, I will have the artificial variables in the order of A1 and A2. ठीक है. So यहाँ पे A1 होगा, यहाँ पे A2 होगा, और इसके order में क्या बनना चाहिए? एक identity matrix बनना चाहिए. So if you look at the first constraint, okay, you can see that the coefficient of A1 is 1 and the coefficient of A1 in the first constraint is 0. Similarly, in the second constraint, the coefficient of A1 is 0, and here we have a coefficient of 1. So I got an identity matrix which I was looking for so that I can start the solution. In the previous table, I can't start the solution without the identity matrix. Now I have got the identity matrix here in the order of A1 and A2. Now I am in a position of starting this what we call as the solution. Okay, this is the solution which we are going to start. One more thing is that although I have introduced the artificial variables, but we have to see what is the cost coefficient of these artificial variables. Okay, we have to see what is the cost coefficient of these artificial variables. We know that the cost coefficient of the slack and the surplus variables is 0. Okay, जो भी अभी हमने क्वेश्चंस किए हैं जो जिसमें slack variables यूज होते थे, उनका जो cost coefficient होता है that is 0. As well as for the surplus variables, the cost coefficient is 0. But for these artificial variables, the cost coefficient is a very huge number, very large number. And I will explain why it is a very large number. ठीक है, तो अगर मैं ये पुराना स्लाइड पे जाता हूँ, if I go to this slide, यहाँ पे जो ऑब्जेक्टिव वैल्यू की फंक्शन बन जाती, that is z is equal to 7x1 plus 5x2 plus 0x3 plus 0x4. Okay, this would have been the objective value function if I wouldn't have added the artificial variables. But now I have added the artificial variables. I have introduced the concept of the artificial variables. Therefore, I have to introduce this artificial variable where artificial variables have to be introduced as well as in this what we call as the objective function. So let's see what the problem will actually become. The problem becomes that minimize z is equal to, it will become that minimize z is equal to 7x1 plus 5x2 plus 0x3 plus 0x4 plus the cost coefficient of the artificial variables is m. Okay, I will write it here. Cost coefficient of this is the cost coefficient of artificial variables, and it is a very huge number. It is a very large number. It can be lakhs, 10 lakhs, crores. It is a very large number. Okay, and this is the cost coefficient of the artificial variable. Okay, since this is a very large number, sometimes this method is also known as, it is a very big number, it is known as what, big M method as well. जो हम method आज discuss कर रहे हैं, it is also known as the big M method because the cost coefficient of M is very large. Okay, it is a big number. M is a very big number, so often this method is known as what, big M method. Okay? You can see in the books as well. Now the constraints will become now, and I have to repeat the same constraints which were here: x1 plus x2 minus x3 plus a1 is equal to 4. What is the second constraint? बताइए जल्दी से क्या था second constraint?
5x1 plus 2x2
2x2 minus x4
plus
a2 is equal
plus
to
a2 10.
okay. So this becomes the objective function. Okay, this becomes the objective function. Now see here, I will write another statement. In objective function of maximization problem. Okay, ma1 ma2 जो भी है ये, they are added to the objective function. Okay, in the in this problem of minimization. Okay, correct it here. In the problem of minimization. In the problem of the minimization, these variables are added m1 ma1 ma2. अगर तीसरा भी artificial variable होता, अगर तीन constraints होते, तब हमें क्या होता a3 भी, ठीक है? So ma1 ma2 ma3 are added in this minimization problem, while as in the maximization problem they are subtracted. If this would have been the maximization problem, then we would have subtracted these in the objective function. And let's look at the significance why we do it. देखिए, this is the minimization problem, and we start our solution with what? With the basic variables as artificial variables, since a1 and a2 will be the basic variables in the first solution. Lekin, but we would want that these solutions get out of the basis. I mean to say, these both variables, artificial variables, should get out of the basis. है ना, हमारा solution जो होना चाहिए था, they should not be in terms of the artificial variables. They should get out of the basis. Isn't it? We don't want that the artificial variables remain in our solution. Okay, therefore we have to see that how can they come out of the basis. ठीक है, हम start करेंगे with artificial variables as the as the basic variables, but gradually we have to pull them out of the basis and we have to replace them with some another decision variables. Therefore, see here, this ma1 will be a very large number, isn't it? This will be very large. Similarly, this will also be a very large number. अगर ये बहुत large number है, यहाँ से problem कैसी है? यहाँ से problem है minimization. Therefore, our minimization problem, the objective function of the minimization problem, won't tolerate this very large number. Objective function क्या करना चाहेगा? वो इसको, अगर ये basis में रहा, ठीक है, अगर ये basis में रहा, तो जो objective value function का जो value है, objective function का जो value है, वो बहुत ही बड़ा number आ सकता है, because m is a very large number. Therefore, the simplex table would operate in such a way that it would like to throw out the artificial variables from the basis. ठीक है? अब for the time being, I am assuming that, let me change the signs here. This is negative, this is negative. अगर मैंने minimization problem में artificial variables का जो ये coefficients है, अगर मैंने इनको minus लिया होता, तो क्या होता? This is a very large number, isn't it? This is a very large number. Problem is minimization. ये large number subtract हो रहा है, okay? Large number is getting subtracted. When a very large number is getting subtracted, that favors minimization. Okay, what we call as that will दैट वोंट फेवर द मिनिमाइजेशन, सॉरी मैं उल्टा बोल रहा हूँ, इट वोंट फेवर द मिनिमाइजेशन। अगर आप किसी नंबर से सपोज 7 से -1 कर रहे हो और किसी 7 से -6 कर रहे हो, विच इज फेवरेबल फॉर द मिनिमाइजेशन? Okay, which is favorable for the minimization, subtracting 6 or subtracting 1? 7 से अगर आप 1 subtract कर रहे हो और 7 से आप 6 subtract कर रहे हो, which is favoring the minimization? Okay, so I hope this is clear why we take this minimization. This is a very large number. Okay, this is a very large number and it will favor minimization. Sorry, it will favor minimization. Since it will favor minimization, देखो क्या होता है, I can repeat it again. Let me come back to this first, जो हमारा ऑलरेडी पे यहाँ पे था। अगर मैंने इसको प्लस रखा है, ठीक है, अगर मैंने इसको प्लस रखा है, अगर मैंने इसको प्लस रखा है, ठीक है, तो since this is a very large number, since this is a very large number, z को क्या हो जाएगा, z will increase. Okay, z will increase. This is a very large number, z will increase. But what is our problem? Our problem is of minimization. But ये करने से क्या हो रहा है, ये करने से ऑब्जेक्टिव फंक्शन इंक्रीज हो रही है। But what we want that z should decrease. Since z should decrease, therefore the table will operate in such a way that the table would want to throw away a1 and a2. हमारा मकसद क्या है? We want that a1 comma a2 should come out of basis. a1 and a2 should come out of basis. तो वो कैसे होगा? अगर हम इसको बहुत बड़ा नंबर इसको दे रहे हैं, साथ में ऐड कर रहे हैं, ठीक है, तो ऑब्जेक्टिव फंक्शन का प्रॉब्लम क्या है? ऑब्जेक्टिव फंक्शन शुड गेट मिनिमाइज्ड। लेकिन इसको ऐड करने से ऑब्जेक्टिव फंक्शन क्या हो रहा है? बढ़ रहा है। तो दिस वोंट बी टॉलरेटेड बाय द सिंपलेक्स टेबल सिंस द प्रॉब्लम इज ऑफ मिनिमाइजेशन। वो उस वेरिएबल को a1 या a2 को दूसरे स्टेप में ही रिप्लेस करना चाहेगा, बिकॉज दिस इज गोइंग टू ऐड ए लार्ज नंबर टू इट। ओके, अब सेकंड केस हम देखते हैं। सपोज यहाँ पे मिनिमाइजेशन होता, लेकिन मैंने यहाँ पे नेगेटिव बनाया होता, ठीक है। द प्रॉब्लम इज ऑफ मिनिमाइजेशन, द प्रॉब्लम इज ऑफ मिनिमाइजेशन when a very large number is subtracted the objective function will minimize। लेकिन हमारा आंसर किसके बेसिस में आएगा? Our answer will come in the terms of a1 and a2, but these are not our actual decision variables, therefore we would want to throw them out of the basis। How would we throw them out of the basis? इसी के लिए हमें क्या करना पड़ता है, यहाँ पे प्लस ऐड करना होता है, ठीक है। We have to add them. When we add them, z becomes very large. This large value of z won't be tolerated by the table because it is the problem of minimization. Since it is a problem of minimization, therefore the table would like that a1 and a2 should be thrown out in the next steps. Okay, that's why we add what? We add them. Okay, is it clear? किसी को कोई confusion अभी तक? I can discuss it here that यहाँ पे अगर मैं maximization problem की बात करता हूँ, if I'm talking about the maximization problem, suppose यहाँ पे कुछ है, suppose we have, suppose here, चलो यही प्रॉब्लम देते हैं। अगर ये मैक्सिमाइजेशन की प्रॉब्लम होती, सपोज यहाँ पे होता 7x1 प्लस 5x2 प्लस 0x3 प्लस 0x4, और अगर मैक्सिमाइजेशन प्रॉब्लम होती देन आई वुड हैव लाइक टू सब्ट्रैक्ट इट। I would have subtracted them. Okay, I would have subtracted them. Why? Because the problem is of minimization, maximization. I would like that the artificial variables should be thrown out of the table. ये कब बाहर निकलेंगे? अगर मैं इनको ज्यादा वैल्यू देता हूं तो प्रॉब्लम क्या हो रही है, ऑब्जेक्टिव फंक्शन क्या हो रहा है? सिंस दीज वैल्यूज आर वेरी लार्ज, दीज आर वेरी लार्ज, जब बहुत बड़ी क्वांटिटी सब्ट्रैक्ट हो रही है किसी ऑब्जेक्टिव फंक्शन में, तो ऑब्जेक्टिव फंक्शन का वैल्यू क्या हो जाएगा? डिक्रीज हो जाएगा। बट द प्रॉब्लम इज ऑफ द मैक्सिमाइजेशन, देयरफॉर the simplex table would like to throw out these A1 and A2 because they are decreasing the function. Here, in our case, these values are increasing the function of increasing the value of z. Therefore, the table would like to throw them out. यहाँ पे ये क्या हो रहा है? यहाँ पे नेगेटिव, ओके, इनको माइनस करने से ऑब्जेक्टिव वैल्यू फंक्शन डिक्रीज हो रही है, लेकिन प्रॉब्लम इज ऑफ मैक्सिमाइजेशन. देयरफॉर the table would like to throw the artificial variables out of the table. Okay, that's why this has to be remembered that in the maximization we subtract these m1, ma1 and ma2. Okay, these have to be subtracted, while as in the addition, okay, while as in the minimization problem, these have to be added. Okay, I think this is the sufficient explanation. So now यहाँ तक तो हमने डिस्कस किया है. Now since this is the problem of minimization, how do we solve the problem of the minimization? We first convert it into maximization problem by multiplying objective function by -1. Okay, so the problem was minimize z equal to 7x1 plus 5x2 plus 0x3 plus 0x4 plus ma1 plus ma2. Okay, so this minimization problem can be converted into the maximization problem by multiplying the objective value function by -1. So the problem will be that maximize z equal to -7x1 -7x2, sorry, 5x2 -0x3 प्लस माइनस लिखो, इसमें कोई इशू नहीं है, -0x4 यहाँ पे -ma1 -ma2. अब आप खुद से देखिए माइनस करने से क्या हुआ. मैक्सिमाइजेशन प्रॉब्लम में क्या आ गया, ये माइनस आना चाहिए था. मैंने ये भी कहा दैट इन द मैक्सिमाइजेशन प्रॉब्लम a1 and a2, ma1 and ma2 have to be subtracted, because when they will get subtracted and z value will decrease and the table will operate that z value इसको बढ़ाना है तो ये आर्टिफिशियल वेरिएबल्स को आउट ऑफ द बेसिस ले जाने की कोशिश करेगा. ठीक है, तो दिस इज अ सिंपल स्टेप दैट अगर किसी फंक्शन को आपको मिनिमाइज करना है तो उसका नेगेटिव मैक्सिमाइज करो. ओके, देयर इज नो big science behind this thing. This is very much logical that to convert the minimization problem, convert it into the maximization problem by multiplying it with the -1 and then solve the problem as we had done in the case of the maximization. ठीक है, constants अब वही रहेंगे. The constants would be the same, which are x1 plus x2 minus x3 plus a1, that is equal to 4, and the second constant was 5x1 plus 2x2 minus x4 plus a2, that is equal to 10. Okay, was it 10? Yes, it was 10. Okay, so दोनों concepts मैंने discuss किए कि greater than constant हम कैसे convert करते हैं into the equality constant. Not only we have to add this subtract the surplus variable, but what we have to do, we have to add the artificial variable as well. Okay, and the problem of the minimization can be converted into the maximization by subtract this, multiplying it with -1, and now we can solve the table जैसे हम अभी तक करते आए हैं. ठीक है, so let's solve the first table now.
सर कॉन्स्टेंट्स में क्यों नहीं होगा ये -a1 और -a2?
कांस्टेंट में नहीं होगा, because they will, वो तो वही रहेंगे ना, constants can't be, we can't change the constants. Think logically. हमें किसको चेंज करना है? We have to change the objective function. Resources तो वैसे ही वही रहेंगे ना, resources won't change. The value of these constants determine the resources, तो resources change नहीं होते हैं. ठीक है, जैसे किसी प्रोडक्ट को आपको कुछ इंग्रेडिएंट्स चाहिए, ओके, कोई मशीन है जिसमें सपोज 10 घंटे काम करना है, सो ओके, जिसकी लिमिट है 10 घंटे काम करने की, तो उसको हम -10 तो नहीं बना सकते ना, जैसे हम वो प्रॉब्लम फॉर्मुलेशन करते थे, दैट इज मशीन ए इज अवेलेबल फॉर 10 आवर्स, इफ यू मल्टीप्लाई इट विद -10, व्हाट डज दैट गिव? इट हैज नो सिग्निफिकेंस दैट machine 1 is available for -10 hours, so it has to be only done in the objective function. Okay, now we can start the table. This is the cost of basic variable, this is the basic variable here. And now the variables are x1, x2, x3, x4, a1 and a2. And this is right hand side, this is theta. The basic variables in the first iteration will be these artificial variables, and their cost coefficient, you can see that their cost coefficient in the objective value function is -m. Okay, it is -m. Okay, since it has been converted into the maximization case, therefore we have multiplied it with minus. Okay, it will be -m. This will be -m. This will also have the quotient of -m. बेटा मुझे बताओ यहाँ पे क्या आना चाहिए जल्दी से? पहला रो क्या आएगा? क्या था पहला कांस्टेंट?
1.
1.
1
Okay,
-1.
x4 was 0 in the first.
Yes,
और
sir. और A1 1.
ये तो आना ही चाहिए आइडेंटिटी मैट्रिक्स, इसीलिए. And in the second it was 5x1, 2x2, ठीक,
0
0 और यहाँ पे माइनस. ठीक है, और जिसमें I think it was 4 and 10. So calculate the value of Cj minus Zj for all. We can see that -m plus -5m, that will become -6m. 7 minus -6m will become, ये क्या बन जाएगा? This is -m, this is -6m, -6m, and what should be here? Sorry, objective value के functions भी change हुए थे ना, I think. Okay, यहाँ पे मैंने गलत लिखा है, यहाँ पे -7 कोफिशिएंट है. Okay, we have to keep this in mind that the coefficients are -7 and -5. Therefore I have forgot it here. There is -7 and here it is -5. Okay, जो हमारी maximization problem बन गई ना, we have converted the minimization to the maximization. Therefore all those coefficients which I have written in the maximization problem, that have to be written here. Okay, I had forgot this thing. अब बताइए क्या होगा? 6m minus. Okay, we have to just perform the basic operation, that is -6m. It will become 6m minus 7. Okay, now in the second we have -m minus 2m, that is -3m, -5 minus -3m will become 3m minus 5. Okay, you can check it as well. 3m minus 5, उसके बाद I think -m आना चाहिए यहाँ पे. यहाँ पे भी -m आ जाएगा. -m minus m minus minus m will become minus m plus m. It will become 0. Similarly, this will also become 0. Okay. So this is the simple the way जैसे हम calculate करते थे Cj minus Zj. I have calculated in the same way. And here it can become minus 4m, minus 10m, minus 14m, but we put a dash here because we don't want our solution in terms of the m. ठीक है? आप लिख भी सकते हो minus 14m, but it's not necessary because we want our solution not in terms of the m. Okay. Now, can you say what is the entering variable here? What is the entering variable? What will be the entering variable here? Okay, this is not the optimal solution because all Cj minus Zj are not negative. Some are positive. कौन सा positive है? 6m minus 7 and 3m minus 5. Because m is a very large number. ये 5, 10 नहीं है. It is in the lakhs, 10 lakhs, crores. ठीक है? It is a very large number. Therefore, this number will always be positive. Okay. So कोई कहेगा सर अगर m1 हुआ तो 6m minus 7 तो -1 आ जाएगा. But I told you it is of the order of 10 to the power 6. Okay. It is a very large number. Therefore, this will always be very high number. Okay. Similarly, this will also be very high number. Since it has 6m associated with it, this has 3m associated. Therefore, this will be the entering variable. Okay. 10 लाख में से अगर 7 काटेंगे, यहाँ से 3 लाख में से 5 काटेंगे, obviously, what we call as this will be a large number. Okay. 6m is a large number. Okay, because it has the higher coefficient. Okay, इसके minus करने से ज़्यादा छोटा नहीं बन जाएगा. Okay, because m is in the order of lakhs, 10 lakhs. So उसके बाद क्या करना है हमें? Since this is the entering variable, therefore this column becomes the key column, and we have to look for the value of the theta so that we can decide for the outgoing variable. 4 by 1, 10 by 5, that is it is equal to 2, and the minimum positive value is of this row. Okay, and this is key row, and we will have the key element that will be 5. This key element will be 5. Okay, ठीक है? ये कहीं पे गलती तो नहीं हुई? Is it okay? ये टेबल काफी बड़ा बन रहा है. नेक्स्ट स्लाइड में हम करेंगे यूज. I will draw the simplex table here. पहले मुझे बताओ टेबल 1 में कहीं पे गलती तो नहीं है? आपने देखा खुद से? Okay, let me know once is everything fine up to this point. Fine or not? ठीक है ये सारा?
Yes, sir.
Okay. So we have seen the incoming variable and we have seen the outgoing variable. In the next table, A1 will still be the basic variable and A2 is the leaving variable and it will be replaced by the X1. Okay. Therefore, in the next table, I will write A1 and X1 is the incoming variable. Okay. यहाँ पे क्या होते थे? X1, X2, X3, X4, A1 and A2. Here we had RHS. Here we have theta. And the cost coefficients can be written. This had -7, this had -5, 0, 0, -m, -m. Okay. A1 का भी cost coefficient है -m और X1 का जो cost coefficient है that is -7. Okay. This is -7. So now we can see that we have replaced A2 by X1. Okay, we have replaced A2 by X1. Therefore, first of all, we will fill this row. Okay, fill the contents of this row, and this will be given by what? We can say that dividing the key row by the key element. So you can see that this is the key row and key element is 5. Therefore, the values will be 5 by 5, that is 1, 2 by 5, 0, minus 1 by 5, 0, and 1 by 5, and 10 by 5 is equal to 2. Okay, so this is the way we are going to get these values here. I will write them here. यहाँ पे आ जाएगा 1, यहाँ पे 2 था, so it will be 2 by 5. यहाँ पे 0 था, it will be 0. यहाँ पे minus 1 था, therefore it will be minus 1 by 5, 0, 1 by 5, and we will have 2 here. Okay, so this is the row which we have obtained by replacing the previous variable, that is a2. Now see here what we are going to get here. Since a1 and x1 are the basic variables, a1 and x1 are the basic variables, we need an identity matrix in this order. Okay, तो x1 के नीचे 1 आना चाहिए यहाँ पे और 0 आना चाहिए यहाँ पे. So our aim is to get a 0 here. Okay, our aim is to get a 0 here. Therefore, we have to perform the operation between this row and the previous a1. Okay, the previous a1. So let's see what operation we have to perform. I think subtraction, simple subtraction से काम चल जाएगा, है ना? Is it?
Yes, sir.
Previous a1 देखो यहाँ पे 1 है, नया जो हमने की रो को रिप्लेस किया वहां पे ये है. So simply subtract the elements of this previous a1 with this of the new. Okay, so new a1, that is a1 dash will be what? It will be given by the previous a1 minus this x1. Okay, this will be the operation that we have to perform. So we can see that 1 minus 1 will be 0. उसके बाद है 1 और minus 1 है ऊपर, 1 और minus 1. 1 minus 2 by 5, that will be I think 3 by 5. Minus 1 minus 0, that will be again minus 1. Now here we have 0, 1 and 0. Okay, 0, 1 and 0. 0 minus 1 by 5 will be what? 0 minus 1 by 5 in fact है ना. 0 minus 1 by 5 वो plus 1 by 5 बन जाएगा. Okay, correct me somewhere अगर गलती हुई. Here we have 1 and 0. 1 minus 0 will be 1. 0 minus 1 by 5 will be minus 1 by 5. पिछले RHS में 4 था, 4 minus 2 will be 2. Okay, देख लेना कहीं पे गलती तो नहीं हुई. Now we are going to calculate Cj minus Zj, and the values of Cj minus Zj will be minus m into 0 is 0, minus 7 into 1 is minus 7, minus 7 minus minus 7 means minus 7 plus 7, and this will be equal to 0. Okay, now adding, multiplying these two, it will be 3 by 5. Okay, you can see that after the आप खुद से सॉल्व करना है, ये बन जाएगा 3m minus 5 by 11. Okay, and this is a 0, this is plus m. 0 minus m will be minus m. ये भी आप जब इनको मल्टीप्लाई करोगे और 0 को सब्ट्रैक्ट करोगे, you will get that m minus 7 by 5. We will get m minus 7 by 5. Here we will get 0, and here we will get that 7 minus 6m by 5. 7 minus 6m by 5. Okay, you can check it later on. And in the right hand side, again our solution will be in terms of the m. Okay, minus 2m minus 14. Therefore, it's not necessary to write that. We can write a dash here, okay, because we don't want the solution in terms of the m. Fine. ठीक है, आप ये values भी check कर सकते हो खुद से. So now, what should be the entering variable? What should be the entering variable now here?
x2.
x2. ठीक है, चलो यहाँ पे तो higher coefficient है 6m. 6m has a higher coefficient of 6, but it is in the negative. तो आप ये नहीं कहना इसके साथ 6m है, ये लेकिन minus 6m है ना. So this won't be the entering variable. Okay, don't confuse with this value. because it is minus 6m. It is a very small number. Okay, this is negative number. Okay, this is negative. Okay, but these two will be positive. Positive कौन सा होगा? This will be positive, this will be positive. अब entering कौन होगा? That will be decided by this higher coefficient, that is equal to, it has a coefficient of 3, therefore it will be a very large number, and this will be the entering variable. यहाँ से ये क्या बन गया? ये की कॉलम बन गया. की रो कैसा होगा? That will be decided by theta. 2 by 3 by 5, that will be 10 by 3, I think. This will be 10 by 3, and this will be 2 divided by 2 by 5, that will be 5. And the minimum positive value comes out to be 10 by 3. Therefore, this will be the outgoing variable. और यही हम चाहते थे that A1 and A2 should get out of the solution. Okay, we can see that in the iterations, the A1 and A2 comes out of the solution. That's why we put a very large number to the M. उसी का reason है, ठीक है? M we put as a very large number and add them in the minimization problem and subtract them in the maximization problem. Currently the problem is of maximization, क्योंकि अब हमने इसको convert किया है into the maximization problem. Although problem थी minimization की, but we have converted them into the maximization by this multiplication with -1. Okay. So in the next table, this is the final table now. A1 will be replaced by x2. A1 will be replaced by x2. यहाँ पे x2 आ जाएगा, यहाँ पे x1 था. These are x1, x2, x3, x4, A1 and A2. This is RHS. This is theta. और यहाँ पे जो values थे, they were -7. This was -5. -7, -5. This was 0. This was 0. This was -m. This is -m here. Okay. Their cost coefficients are, this is -5. इसका cost coefficient -7 है. And this is the cost of basic variable. This is the basic variable, and this is Cj minus Zg. Okay, now we have introduced the new variable, that is x2, and the elements of this x2 row will be given by dividing the previous x2, previous a2. Okay, dividing the key row by the key element. Now you can see that the key element is this. Okay, intersection of the key row with the key column. So ये बन जाएगा 0 by 3 by 5 will be 0. 3 by 5 divided by 3 by 5, that will be equal to 1. So first element will be 0. This element will be 1. उसके बाद -1 divided by 3 by 5. I think that will be equal to -5 by 3. So just wait a second. Okay, we can write this as -1 by 3 by 5. It will be equal to -5 by 3. Okay, so similarly you can write all these elements. The elements I will directly write here, you can just check them. This will be equal to 1 by 3. This will be equal to 5 by 3. This will be equal to -1 by 3. And from the right hand side, it will be equal to 10 by 3. Okay, so we have replaced the previous artificial variable row. The previous key row has been replaced by this new column, new row. Okay, and now we can see that the basic variables are in terms of the x2 and x1. They have to be brought in terms of an identity matrix. Okay, we need to get an identity matrix in the order of x2 and x1. Therefore, we should have 1 and 0 here. We will have 0 and 1 here. Okay, so already you can see that under x2 we have got 1. Now below the x2, what should we get? We should get a 0 here. Okay, we should get a 0 here. So we have to perform the operation between the new row which we have formed and the previous x1. Okay, we have to perform the operation between this x1 here and the new which we have formed here. Okay, so how will we get? Anyone among you can tell me what is the operation that need to be performed? Yes, fast. तो जल्दी से बताइए.
-2/5 times x2.
-2/5 times x2.
So पहले x1.
Okay, x1. Okay. So after that, you will perform this operation, and the elements you will get here is the elements after this operation. They will be equal to we'll get a 1 here. We will get 2/3. We'll get a -1/3. I will leave this as an exercise to the students to calculate them. This will be -2/3. This will be 1/3, and this will be 2/3. Okay. So we have calculated all these elements here. Now we calculate the value of the Cj minus Zj. And you can see that the value of the Cj minus Zj here will be, this will be 0. This will be 0. And this will be -11/3. This will be 2/3. This will be, okay, I will write it here. This will be -3m plus 11 divided by 3. This here will be -3m plus 2 divided by 3. Okay. Now, can you tell on the basis of Cj minus Zj, have we reached the optimal solution or not?
Yes, sir.
Okay. You can see that all the values of the Cj minus Zj are negative. Okay. Either 0 or negative. So see these basic variables are 0. Okay. Under the basic variables, we have Cj minus Zj equal to 0. And rest of the non-basic variables are all negative. Okay. Because m is a huge number. Therefore, we have all these values to be negative. And what will we have here is, we will also have here is -64/3. So optimality has reached. We have reached the optimal solution. Okay, we have reached the optimal solution because all Cj minus Zj are either 0 or negative. Okay, so one thing we have to remember that since this was a problem of minimization and we had converted it into the maximization problem by multiplying it with -1. In the final solution, what we have to do, we have to again multiply this z with -1. Okay, this is actually -64/3. We have to again multiply it with -1, and we will get that the minimum value is equal to 64/3. Okay, so don't forget in the last that we have to again multiply it with the 1 so that we can convert it back into the minimization solution. Okay, obviously -64/3 doesn't give any meaning. Okay, if you have to reduce the cost negative to nahi ja sakta na. If you are in the process of reducing the cost or reducing the time, this can't go into the negative. Okay, therefore don't forget it back to multiply it with -1 so that you can convert it back into the positive value. Okay,